Alright students, welcome to final part of our question paper, section E, analytics and application. In this section we will discuss some very important machine learning concepts that help you understand why things work the way they do. I will explain each one in simple and practical way, just like you are sitting in the class. Question number 41. No single ML algorithm performs best on all problems. Refer to the blank theorem. Which theorem? So basically this theorem says there is no one perfect machine learning model for everything. A model that works great on one dataset may fail on another. So this we see in our everyday life. That's why we always try multiple algorithms and choose what fit our data best. So here the theorem is no free lunch theorem. Question number 42. The method that uses smaller training subsets repeatedly to estimate test error is called. Here what happens is cross validation. We break the datasets into multiple small parts called folds, multiple folds. We train on some folds and test on remaining one. Then we repeat this process again and again. This gives us a very reliable estimate of model performance. So the answer here is cross validation. Question number 43. In KNN, runtime grows with blank when n is number of points and d is dimension. So because the KNN tries to classify a new point, it has to calculate the distance between the query point and all n training points across d dimensions. So the time increases with both n and d respectively. So here answer is O and D. Next question. The curse of dimensionality affects algorithm that depends on which methods. When dimension increases, distance calculation become meaningless. Points start looking equally far apart. That's why high dimensional data is difficult for distance-based algorithm like KNN clustering itself. So here is the answer, distance matrix. Basically depends on distance matrix. Moving ahead with next question, PCA transforms correlated feature into which component? PCA takes your original correlated features and rotates the data into new access system where each component is completely independent, orthogonal. This helps in dimensionality reduction and remove redundancy. So here answer is orthogonal, uncorrelated. Question number 46. Mapping words to numerical vector in NLP is known as word what? So this is known as word embedding. In NLP, computers can't understand text directly, so we convert each word into a dense vector of numbers. These vectors captures meaning, context, and relationships within the word. That process is called embedding. So now next question, question number 47. In a neural network, removing random neurons during training is called what? Dropout is a very famous regularization technique. During training, we randomly turn off some neurons. This forces the model to learn more robust patterns and prevents overfitting. Question number 48. Spark uses for fault-tolerant distributed data storage. Answer here is RDDs. RDDs are Spark's core data structure. They are fault-tolerant and stored across multiple machines. Question number 49. And I think here is the last question. Yeah, right. In Hadoop, YARN stands for, what's the full form of YARN? So basically YARN stands for yet another resource negotiator. YARN is basically the resource manager in Hadoop. It decides how much memory, CPU and resources each job gets and schedule tasks efficiently across the cluster. So that's complete section E, the last section of this question paper. We covered essential concepts here. So see you in the next one. Thank you.